In this problem, we want to find the limit as x approaches 0 of this expression, which involves a radical minus a radical all over x. Now, if we plug in x equals 0 here and here, we're going to get 0 over 0 for the fraction, which is indeterminate. So we have to multiply this expression by some kind of form of 1 in order to manipulate it and rewrite it so that we can eventually take the limit by plugging in 0. Now with radicals, if you have a radical plus or minus a number or another radical, a technique that often works is to multiply by the conjugate, which is this, you change the sign in between the two terms. So it's the first radical plus the second radical in this case, because we changed that minus to this plus. And that's over itself, so we're really just multiplying by a form of 1. And let's add some parentheses everywhere. So here, here, and here. Now in the numerator, we do want to distribute and FOIL because it will simplify a lot. That's the point of multiplying by the conjugate, is that root 2a plus 3x times root 2a plus 3x, that's a radical times itself, so the radical goes away because you're squaring it. So you get 2a plus 3x. Now my outside term would be root 2a plus 3x times positive root 2a, but my inside term is negative root 2a plus 3x times root 2a. So those outside and inside terms will cancel because the outside term is positive and the inside term is negative, and they're the same otherwise. So then the last term when I FOIL is negative root 2a times positive root 2a will be negative 2a as those radicals cancel. Now in the denominator, we do not want to FOIL or distribute this x over those two terms because then that will make it harder on us in the next step. So I'm just going to leave it as x times parentheses the sum of the two radicals. Okay, now we're looking for things that simplify, and up here in the numerator, I have 2a minus 2a, and after you cancel those, then you're left with 3x in the numerator over x times that. So actually, after you cancel the 3a's, then you can cancel the x's. And in fact, then we can take the limit, so I'm not going to write limit as x approaches 0 because we can now go ahead and take the limit by plugging in 0 for x right there, and we shouldn't get an indeterminate form. So in my numerator, I'm left with 3. And in my denominator, I have the square root of 2a plus 3 times 0 plus the square root of 2a. Well, 3 times 0 is 0, so you have square root of 2a plus square root of 2a. So that's 2 times the square root of 2a. That's that limit in its exact form.